I'm Dr. Mike Murphy. I earned my PhD in computer science from Clemson University, and I teach computer science and information systems at Coastal Carolina University, located in Conway, South Carolina. In this lecture, I'm going to introduce the OSI model. The OSI model has a purpose in networking. We'll talk about what that is, talk about the layers of the OSI model, and then talk about a useful mnemonic for remembering these layers. Please do not throw sausage pizza away. Now, the purpose of the Open System Interconnection Model, or the OSI model, is to provide a conceptual model that allows a networking system to be abstracted into multiple layers. Each layer in the networking system is simplified to communicate with the layer below it and provide an interface to the layer above it. So this is a conceptual model whose purpose is to try to simplify the way that we design, communicate, and think about how a networking system would be implemented by separating out all the details into discrete layers where each layer maintains a certain amount of independence from the other layers. There are 7 layers in the OSI model. Starting from the bottom, we have layer 1, which is the physical layer. Layer 2 is called the data link layer and sits immediately above the physical layer. Layer 3, the network layer, sits immediately above the data link layer. Layer 4, the transport layer, sits above the network layer. Layer 5, the session layer, sits above the transport layer. Layer 6, the presentation layer, sits above the session layer. And finally, layer 7 is the networking application itself, which conceptually communicates with the presentation layer. Now, of all these layers, the physical layer is the only one that strictly requires hardware. The remaining layers of the OSI model can be implemented entirely in software. I do have to give a slight footnote to that, in that we can implement entire virtual networking systems that exist entirely in software and have a virtualized physical layer. However, that's a bit beyond the scope of our discussion today. So at the lowermost layer, we have the physical layer. This is at the bottom of the OSI model. This layer specifies electrical and physical properties of a network connection. These electrical and physical properties include such things as the voltages that are going to be used by the connection, assuming the connection is an electrical one, the pin layouts for how the different voltages are going to be connected to circuits, the types of signals and modulation that are going to be used, the types of cable that are going to be used with the connection, and so forth. Not all physical layer connections are necessarily electrical. For example, we have radio wave connections with wireless networking, and we also have optical physical layers for fiber optic connections. An important purpose of the physical layer is to physically isolate different electrical or optical circuits from each other. This is important because without this type of isolation, a malfunctioning device attached to a network could prevent the entire network from operating. The physical layer works on streams of bits. This layer is responsible for getting groups of bits from one machine to another, and it does this by encoding and decoding the bit streams into an analog transmission signal. Ultimately, despite the fact that we talk about digital communications, ultimately, at a physical level, all communications are done using analog signals. Now, once we have a physical layer in place, we can move on to the data link layer, and this provides a link directly between directly connected systems. In other words, if we have two systems that are cabled together with a piece of wire, or two systems that are fiber optically interconnected, the data link layer provides a connectivity mechanism between those two systems. and this does so at a higher level than the physical layer. This allows, for example, a line to be shared between two or more systems, arbitrates who can send at any given time. This also performs some physical medium error detection and correction. The physical layer just tries to get the bits from one end to the other. It's up to the data link layer, in most cases, to perform the initial error correction. We often discuss the data link layer in terms of Ethernet systems. In Ethernet, the data link layer is used to transmit data between nodes on the same network segment. So it's used to transmit data from one node on the same network switch or the same network segment, and that data is received by another node, which can then turn around and transmit a reply back to the original node. So this is what we mean by a data transfer. We have transmission and reception. In Ethernet and in many data link layer implementations, data are transferred in what are called frames, which are logical units of data of a given size, typically a fixed size. Above the data link layer, we have the network layer, and the network layer is an abstraction mechanism to provide a means for sending datagram or sequences of data to any system connected to the network. These systems do not need to be on the same network segment like they do in the data link layer. If there are multiple segments in the network, it is the network layer's responsibility to route datagrams between those different network segments. In addition, it is sometimes necessary to split and reassemble datagrams because the underlying data link layer can only handle messages of a certain size. It's up to the network layer to perform this fragmentation and to reassemble fragmented datagrams at the other end when needed. The ubiquitous example of the network layer is the Internet Protocol, or IP. The transport layer sits above the network layer and provides reliable end-to-end data transfers for network applications. The transport layer is responsible for managing data flows over connections between two systems, and in many cases the transport layer ensures a certain amount of reliability in terms of the communication. One thing the transport layer typically does is reorders datagrams upon receipt so that data is in the original order provided by the sending application. It is possible to transmit data over a network and have that data arrive in a different order from which it was sent. One thing the transport layer does is reassembles those datagrams into the appropriate order so that the higher layers see the same data stream that was transmitted from the sending application. Ubiquitous example of the transport layer is the Transmission Control Protocol, or TCP. Now the next two layers, the session layer and the presentation layer, are not widely used in practice. However, with remote procedure calls, the session layer is often used for establishing, managing, and terminating transport connections to support communicating applications. This is the primary function of the session layer, is to manage the different transports that are necessary in order to let two applications communicate. It is not used in general with TCP/IP connectivity. The presentation layer is a conceptual layer that translates data between an application representation and a network data flow. In theory, a presentation layer could be used, for example, to implement transparent encryption for different network applications. In practice, however, it's often up to the application to perform the functions that would be conceptually performed by the presentation layer. This layer exists in concept. It does exist in a few isolated cases. However, in general, we don't actually use this layer. Instead, the application layer talks directly to the transport layer. Finally, the application layer is the network application itself. That is the application that a human or system user is using to perform some type of task that requires network connectivity. The application layer can implement its own high-level protocols for sending and receiving data. A good example of an application layer protocol is the Hypertext Transfer Protocol, or HTTP. That's the protocol that makes the World Wide Web function. You are using an application layer application in order to view this video. The web browser is an example of an application layer implementation. Other examples include things such as FTP clients, internet radio streaming applications, file sharing clients, basically any application that makes use of network connectivity. And these applications are all up here at layer 7. As I mentioned before, in practice, application layers on most systems communicate directly to the transport layer, and we don't actually use implementations of presentation and session layers. This is because many applications, for performance reasons and for specialization in what they do, perform their own data flow conversion and session management. So one way to remember these layers is to memorize the mnemonic, "Please do not throw sausage pizza away," where the please corresponds to the physical layer, the D in do corresponds to the data link layer, not corresponds to the network layer, throw corresponds to the transport layer, sausage corresponds to the session layer, pizza corresponds to the presentation layer, and away corresponds to the application layer. So this is a way of remembering these layers in order from layer 1, the bottom layer, through layer 7, the top layer. In summary, the OSI model provides a conceptual abstraction for different layers in a network. Again, this is a conceptual way that we can use to discuss and design networking systems without becoming lost in the great amount of complexity required to make them work. Each layer in a networking system is responsible for communicating with the layer beneath it and implementing an interface for the layer above it. In practice, we don't use all 7 layers, and there are sometimes some dependencies between layers. However, this is still a good conceptual model for understanding the pieces at a high level that make up a network system. Thank you for watching. For additional lecture materials, please see my website at www.mikemurphycs.com. Please note that due to a high volume of email, I am unable to respond to questions that are not from Coastal Carolina University students. For more information about Coastal Carolina University, including admissions information, please visit www.coastal.edu. This video is licensed under the Creative Commons Attribution Share Alike 3.0 Unported license. For more information, please visit the Creative Commons website.